Especially code 1095 found in mountain array. For this question, to give us a mountain array and int target. And let's find the first index, which in the mountain array, which have the value to be target. So what is a mountain array? The array length is greater or equal to 3. And also there is an index I. Before I, it is monotonically increasing, and after I, that is monotonically decreasing. It says that we cannot access the array directly, but we can use the length and get an index to get a sum of the multi-array value. And let's find the first index which equals target. If the index does not exist, return -1. It says that we can not make more than 100 calls. So we think for this question, intuitively we think about is that we can use binary search. So there are 3 steps. One is binary search, the peak index. And the second part is the binary search for the first part, increasing part, right? Increasing part for target. And the third is binary search for the decreasing part for target. If we cannot find it, then we return -1. So we'll firstly get the mountain array length int a equals mountain array dot length. Length. So for mountain array, right, we can firstly have corner case. For example, that if this kind of mountain array get 0 greater than target, and this one get I -1 greater than target, right? So of course it's impossible that every number in the mountain array will be greater than target. We just return -1, right? The second part is we are binary search the peak index. We can write a help function int search index. So this will be the mountain array. And we know its length is n, right? We can pass this kind of parameters. So we'll have int start equals 0 and equals a -1, right? So so we'll say while this is start +1 smaller than n, int mid equals and start plus and minus start divided by 2, right? So we'll say if this mountain array get start, it start smaller than mountain array get mid. And this one get mid. greater than this one get n, right? So that means this mid is our peak index. And we can say else if, right? Else if if we have this one smaller than mid and mid is smaller than n, right? That means we are in the first part. The peak will be in our still we need to find on the right to the right. So we'll have start equals mid and else n equals mid, right? And after we are trying to find the peak, so we need to compare start and which one is bigger, right? Return trying to say if start is smaller than n, right? Then we return n. Otherwise, we return start. Okay. So this is the first binary search for peak. Okay. So we'll have int peak index equals search. We can call search peak, right? Search peak. Search peak. Mountain array in the end, right? So this is the first thing. The second function we're going to write is binary search the first part, private int search increasing. Okay, increase part. First search first part. Okay. And so we'll have int index because search first part, right? And what we're going to do is this mountain array. And also we start from 0 to peak index, right? So we'll have actually this 0, we don't need to have this 0, right? Because we can have int peak. Okay. So we'll have int start equals 0 and equals peak, right? So for this kind of, it is also while start plus 1 smaller than n. We're going to have int mid equals start plus and minus start divided by 2, right? So if we have this one get mid equals target, then we just return mid, right? Else if this one, so in the first part that is a monotonic increasing, right? So if this one is greater than target, that means the target will be on the left part, right? So we'll have end equals mid, else start equals mid, right? And we are searching the first. So we'll say if this one get a start equals target, then we're going to return start, right? And if this one, and if we have end equals target, then return end, right? Otherwise, we return -1, right? Pick. So for the second part, if this kind of index done equal to -1, right? Return index. Otherwise, we still need to search the third part. So the third part is a private. The second part search second part, right? So we can have a pick. It is start from pick +1, right? Pick start in end, okay. So we'll have we can just return, right? Because if it doesn't find, we just return -1 on search second part. Mountain, this array, right? This array, and the pick +1, right? And a -1. So for this part, int start equals start, okay. It already have this kind of parameter. We don't need to define this parameter anymore, right? I say while this start +1 smaller than end, right? Int mid equals start plus and minus start divided by 2, right? So I say if this one if this one get mid equals target, right? So we return mid. Else if this one get mid if this one is greater than target, that means we need to search on the right part. So I have start equals mid, else and equals to mid, right? Because we are trying to find the first. So I say if search, so I think we can copy this part, right? This part. So there are 3 binary search. Pick index, okay. Find symbol. Pick index +1. GT. We need to have the target, right? What we need to search. And this one, we also need a target, right? We're searching something. Mm. Let's try to see this result. Um, so we'll see this peak will be here, right? And so the peak is the result. So that means so we can try to see whether this peak is a result system. Print. And see what we find for this peak index. So this peak index we didn't find successfully. Looks like we didn't get a correct peak index. So the first function has some problem. And if start is smaller than mid and mid, it's not a start, it should be mid -1, right? And this mid greater than mid +1, right? And also this, if this mid -1, and this one mid +1, right? So so this three part. First part is find the peak, and then do two binary searches. Too many calls to about the gate. For this one, this one, for this kind of scenario, right? Let's try to see. Let's copy this this one. Actually, for this, it seems that this peak is smaller than our result, right? So for this kind of scenario, we try to add another corner case, right? If this mountain gate peak smaller than this result, we just return. We don't need to do the search. If this one smaller than our target, we just return -1, right? Don't need to do any more research. So, okay, so this will be 3 binary searches, and we do add one corner cases here, right? Otherwise, the problem is that for this kind of scenario, right? It is what we are looking for. It is we searched the both left part and the right part. None of that has been reached the result, but it reached how many numbers it is. Let's try to see how many numbers. And I think if it is called log times, right, should not have too many calls. We can try to see. And so for that kind of test cases, N is 9,000. So it is a very long one. And how many? So to find a peak, how many times we called? So here, right? And we can do it. We can write down how many times we called for the first one. So int 4 times, right? Equals 0. Here we call twice, right? This one will call times plus equal to 2, right? And also this here call times or plus equal to 2. And here we'll here we didn't call, right? But actually the calls, right? Because it will call this and call this, right? So in order to get the call fewer, you can do this, right? Int left equals this one. Int call number 1, value 1, right? Value 1, value 2 equals this. And int value 3 equals this one plus 1, right? So that we can save sometimes of call, right? So we'll say value 1 smaller than value 2, and value 2 greater than value 3, right? Value 3. And if we have value 1 smaller than value 2, and value 2 smaller than value 3, right? So that we don't need to calculate every time we can save sometimes of calling, right? Let's try to see in this case with that kind of sample, if we do not add the special corner cases, whether it will pass through or not. Yes. Mm. Okay, so you will see, doing like this, we can save half of the calling to find the peaks, right? So doing like this, we don't need to write the corner case actually. If we don't have, for example, don't have this, right? We're trying to see whether we can still have this one pass through, right? Yeah, so it still pass through. So here, right? Don't put the calling at the if statement. Let's get it out, right? So that in the while loop, it just calls 3 times. Otherwise, it will call 1, 2, 3, 4, 5, 6, 7, 8 times, right? Yeah. Of course, it's better you can add corner cases, right? If the peak is smaller than target, return -1, right? So the time complexity will be in log n